Okay, these are the solutions to the numeracy paper 1 preparation sheet posted today, so that you could check over your work and make amendments where necessary. So the first question then shows the rainfall in two places in Wales. One is called a town called Trefwen, and the other one is a town called Newbury. This was in April 2016, and they've given us two box plots to show this data. And some of the things that we know from a box plot is that this line in the middle of the box represents the median. The front of the box here represents the lower quartile. The end of the box represents the upper quartile value. The end of the box plot is the highest value in the data, and the front of the box plot is the lowest data value. And the same as well on Newbury. So once we've established, we understand what part is what, we can now start going about questions. So we're being asked to calculate the difference between the median daily rainfall of Trefwen and Newbury. So we want these median values here. Okay, so it's a question of reading off. So the median on Trefwen is 30 millimeters. And the median here from Newbury reads off here at 28 millimeters. So the difference is 30 minus 28. So there's a difference of 2 millimeters between the medians. In which town was the range the greatest, and by how much? So the range then is the highest value. So here is the highest value, take away the lowest value. Okay, that's how we find the range. So the range then for Trefwen is this value here, which is 55. Take away this value here, which I believe is 5. Okay, so 55 take away 5. So let's be clear then that we're doing this for Trefwen. So the range is 55 minus 5, the highest minus the lowest value, which is 50. So it's got a range of 50. And for Newbury, again, we need to go to the highest value and the lowest value. And here the highest value is easy to read off, is 50. And this one here is 1. So the range for this would be the difference between those. So 50 take away 1 would be 49. So Trefwen's got the greatest range. Okay, so Trefwen has the greatest range. And it's by 1. There's a difference here of 1 between 49 and 50 by 1 millimeter in this case. All right, and finally then, on this question, we're being asked to calculate the interquartile range and which town has the greatest interquartile range and by how much. So to work out the interquartile range here for Trefwen, we need this upper quartile value and lower quartile value. And as it's a range, it's the difference between the two. So I think that's 45 there, and that's reading off 20 there. So for Trefwen, the interquartile range will be 45 minus 20, which in this case is 25. And for Newbury, the interquartile range on this one. So let's go and find those values. So here we've got our upper quartile here, which I believe is reading off 45 there. And our lower quartile value here, I believe, is reading off 15 there. So 45 minus 15 is 30. So in this case, Newbury has got a higher interquartile range. So let's write that as a sentence then. Newbury has the greatest interquartile range. I'm going to just write IQR in short by, let's have a look at the gap. Between 25 and 30, there's a gap of 5 by 5 millimeters. Okay, histograms then. A histogram is given to us, this one's already drawn, and it's given us frequency density, these values here, okay? And this was the number of calls coming through in a call center on a Friday evening, and this was the length of the calls here. What it doesn't tell us is how many people took between called in between and took between 0 and 10 minutes. Their call took between 10 and 20 minutes, for example. So The frequency, okay, because part A is asking us to calculate how many telephone calls. The frequency is the area of each bar of the histogram. So we need to be able to calculate the area of each bar. So on this one here is reading off a frequency density of 1, and the width across the bottom there is 10. So that would be 10 times 1. So that would be 10. So 10 people had a call between 0 and 10 minutes long. The second bar here, it's reading here, has got a height of 6, look, 6 times 10. Okay, so in here, 6 times 10. So 60 people in here. This bar here goes up to frequency density of 10. So 10 multiplied by 10 is 100. So there's 100 people took between 20 and 30 minutes. This one here would be 4 times 10. So there'd be 40 people there. And in this bar here, it would be 2 times 10. So there'd be 20 people took between 40 and 50 minutes in their length of calls. And this one here, the idea of a histogram is that some bars are wider than others. Okay, so this one goes from 50 minutes up to 70 minutes. So the width on this is 20. Okay, so it's 20 wide. And again, it's got a height of 1. So 1 times 20 is 20. So 20 people took between 50 and 70 minutes in the call. So how many were made altogether? Well, to answer this, we need to add up all the frequencies: 10 plus 60 plus 100 plus 40 plus 20 plus 20. So there's the frequencies for each bar. And in total, that is 250 people altogether. Okay, for part B, then calculate an estimate of the percentage of telephone calls that lasted longer than 3/4 of an hour. Okay, so 3/4 of an hour in this case we should know is 45 minutes. So longer than that, so 45 minutes is going to be from here and longer. So that means that I only want, in this case, half of the people in here. Look, so from 45 to 50 is only half of what's in this group here. So if it's 20 for the whole bar, it would be 10 in the first 40 to 45 minutes and 10 for 45 to 50. So we split that equally into 2. So it's going to be the 10 plus 20. So that would tell me that there were 30 people whose telephone calls lasted longer than 45 minutes, 45 minutes, 3/4 of an hour. So 30 people. So we're being asked to estimate that as a percentage. So from the first part, we know that in total there were 250 calls made. We need to put that into a percentage with a calculator. So hopefully you can see that if you multiply through top and bottom here, numeracy and denominator by 4, we will get 120 over 1,000. And then if I divide through by 10, because the idea behind a percentage is to get it out of 100, then it would be the equivalent of 12 over 100. So roughly 12%. Okay. And for part C, then it's asking us to estimate the median length of a call. So if 250 people make calls, then the median would be in the middle. So that would be where the 125th person in order would appear. So we know that we've got 10 people in this first bar, 60 people in this second bar here. So altogether that's 70. And then we've got this 100. So altogether that's 170. So the 125th person is going to be in this bar here between 20 and 30 minutes. Okay, so we know that we had 70 people in the first 2 bars. So to get to the 125th person, then if I find the difference of that, it's the 55th person in this bar here, which is 100 people. So it's just over halfway into this bar. So there's 2 ways of going about this. And that is to say that it's 55th person out of the 100 people in there. And we can multiply that by the width of the bar, which the width of the bar is 10. So in this case, that's 0.55 times 10. which is 5.5. So it's the 5.5 after 20. So it's going to be just over halfway, 3, 4, 5. It's going to be here. So there's that gap of 5.5 here. So taking me up to 25.5. So the median length of the call is 25.5 minutes, roughly. Okay, it is an estimate. All right, the other way of doing that is to because we know there's 100 people in this bar here, we know that each strip, there's 10 of these strips, is worth 10. So again, you could do the first 5 and then just half of the next one. So again, taking you to the 25.5 value. Okay, a velocity time graph then. So this one shows the speed of a cyclist between 2 sets of traffic lights. So speed going up, and then he starts slowing down until he hits the traffic lights and stops. We're being asked to calculate the acceleration of the cyclist at t equals 7.5. So first of all, we need to find where t equals 7.5. It's here. And remember, we need to draw in a tangent that touches the diagram but doesn't go underneath the graph. Okay, so now we've done that, to calculate the gradient of this line, we just pick 2 nice points and turn it into like a triangle. So we've seen this when we're doing the gradient of a graph from a straight line graph, y equals mx plus c. We could see here that the base here goes from 5 to 10, so that's 5 along. And we want to find the height, so it comes here at roughly 14, and then this one here, 17.5. So when we do the gradient, which is representing the acceleration, from 14 to 17.5, so this is 3.5. So we divide, it's the difference in the vertical height, so 3.5, so that's 3.5 meters per second, divided by the time, which is 5 seconds, okay, between these 2 points. And as we've got a decimal here, if I multiply through by 2 top and bottom again, okay, I'm going to get 7/10. Now that's 10 seconds, and that's meters per second. And 7 divided by 10 is 0.7. In this case, the units are meters per second squared, because we're dividing seconds by seconds. Okay, to estimate the distance then between the traffic lights, it's the distance is the area under this graph here, which is very difficult to calculate. Okay, so we need to break it down, hence the hint that we need to consider these steps here. So between 0 and 5 here. So if I was to draw this here, okay, it's an estimate. I've got a triangle, and to work out the area of this triangle, I'm going to call this area number 1. It's a triangle, and it's going to be base times height. So that's 5 times 10 divided by 2. Okay, so in this case, 50 divided by 2, 25. So the distance there is roughly 25 meters. And then we're going to do from 5 to 10. So that's going to be this point here to this point on the graph here. Okay, so again, we join them up. And this time it makes a trapezium. Okay, so we've got a triangle. And here we've got a trapezium. So remember that the rule for the trapezium, find an area of a trapezium, and I'm going to call this area number 2, is half, and it's going to be A plus B. So that's going to be the 10 plus this one here, which I've got 16. So 10 plus 16. And then multiply that by the height, which is this 5 here. Okay, so 10 plus 16 is 26. Half of 26 is 13. 13 times 5 is 65. So the area of that one is 65 there. Okay, and then we're going to do something similar with the next 2 areas. So then we found the areas now then of these first 2 shapes. So the third one then, we need to go from t equals 10 to t equals 15. So t equals 15 here. Okay, and if we join that up, join this up here, we've got another trapezium in here. Oh, there we go. So we've got another trapezium. Okay, so we'll call this shape number 3. So again, there'll be half. Now, two parallel sides of this one here, 16, and this one here, okay, and it's reading off as 13.5. So 16 plus 13.5. And again, the height of it is this length here, so that would be 5. So multiplied by 5. Now I know that 16 plus 13.5 is 29.5, and I already don't have a calculator, so working out 29.5 times 5 and then half in that is going to be quite complicated. And I am only being asked for an estimate here, so I'm going to round this to 30 to make my calculations without a calculator so much easier. And if I do 30 times 5 is 150, find half of that is 75, much simpler. Okay, and then the final part of the area is this bit here. So going from there to t equals 20, and we've got a triangle again. So the first shape and the last shape here are triangles, two middle ones are trapeziums. So I know it's got to be base times height. So the base here, again, it's got a width of 5 from 15 to 20 and a height of 13.5. So it's going to be 5 multiplied by 13.5 divided by 2. And again, trying to multiply these and divide by 2 again without a calculator because we're only estimating. I'm going to round it up to 14. So 5 times 14 is 70. 70 divided by 2 is 35 meters. Now, I've worked out now a rough area underneath the graph. So my estimate for my distance, I'm going to need to add all of these up. So my total is adding up my 4 areas. So 25 meters plus 65 meters plus 75 meters plus 35 meters. And in this case, when these all are all added together, they give me a total of 200 meters. So that's an estimate for the distance the cyclist took between 2 sets of traffic lights. Okay, recurring decimals, the fractions then. So just a quick recap on this topic here. So we know that this 0.04 recurring looks like this with the 4 recurring. So the technique is to let R equal 0.0444 recurring and call that equation number 1. And then because only one number is recurring, we're going to multiply it through by 10. So multiplying R by 10 gives me 10R. And multiplying 0.0444 recurring by 10 gives me 0.4444 recurring. And we call that one equation 2. And if we subtract the first equation from the second equation, it'll help us find what R is. So I'm just going to swap these around a moment to help me use the column method for this. So there's equation 1. Equation 2, sorry, on top, and there's equation 1 underneath. So I'm going to be using the column method. So I'm lining up here the decimal point, and I'm taking them away. So here's my equals. So 10R take away R leaves me with 9R. And here, put my decimal point in the correct place. 4 take away 4 is 0, 0, 0. Until we come to this 4 take away 0 and 0 take away 0. And at this stage, we can ignore these zeros. Okay, so we've got 9R is equal to 0.4. And if I multiply through now by 10, because I've got a decimal, I've got 90R on the left-hand side is equal to 4. And then if I divide through by 90, it leaves R on its own. So 4 divided by 90, or 4 over 90 is my fraction. And I can simplify that by dividing through by 2. So 0.04 recurring is the equivalent of 2 over 45. And for the second one here, it looks like this. There's a dot above the 3 and the 7, so it's 37 recurring. So again, if I let R equal that decimal, okay, and call it equation 1. Now, because 2 numbers are recurring here, I'm going to multiply through by 100. So multiplying R by 100 gives me 100R. And multiplying 0.237 recurring gives me 23.737337, etc. Okay, and that's equation number 2. And I'll do what I did on the first example. And I'll subtract the top one from the bottom one. So I'm just going to rewrite these out in the correct order. So 23.7373. Okay, and the first one, r equals 0.237373, etc. Okay, so we're going to subtract these now. Okay, so like the first example, we've got our equals in the correct position. We've got our decimal point in line here. 100r take away r leaves me with 99r. And then we could start taking away, look. So 3 take away 3 and 7 take away 7 until we get to 7 take away 2, 5. And 23 take away 0 is 23. So now I can ignore all these zeros. So I know that if I rearrange 99r equals 23.5, I will get my fraction. Because this contains a decimal on the right-hand side, again, I'm going to multiply through by 10. So multiplying the left gives me 990r, and the right-hand side 235. And then to find r, we just divide through by 990. So 235 over 990. And in this case, I can see that both numbers end in a 0 or a 5. So if I divide through by 5, I could simplify this fraction to give me a final answer of 47 over 198. And the final section is all about finding the volume of a cylinder and a cone. Now, with both of these, to find the volume of a cylinder, which is a prism, is pi r squared times the height. Usually we use these, we do these sorts of questions with a calculator, but we are being asked to leave our answer in terms of pi, which is quite a common thing on a non-calculator paper. Okay, so one of the first things we need is a sketch of a cone and a sketch of a cylinder to help us with the information that we're going to use. So the cone then, we'll come to the cone first. So the cone then's got a base radius of 6 centimeters. So if I draw that in, so the radius is from the center to the outside, so that's 6 centimeters. And it's got a height of 30, so that's the vertical height, not the slanted height, of 30 centimeters. And the cylinder, just complete the base here, it's got a base radius of 10 centimeters. So the radius again from the center to the outside. Sometimes we need to be careful because they may give us a diameter in some of the questions and we need to find the radius first. Okay, height of this cylinder here is 20 centimeters. Now to find the area of a cylinder, which is a prism, is the area of the cross section, which running through the shape is a circle, so that's pi r squared times the height. And to find the volume of a cone, then we need to use the following formula, which is 1/3 pi r squared times the height. Okay, now this can be found on the formula page of the example booklet. Okay, so you don't need to learn this, but you need to know how to use it with the information we're being given. So this first one here then, the volume of the cylinder, so it's pi times the radius squared, so that's times 10 squared, times the height, which is 20. So I know 10 squared is 100. So 100 times 20 is 2000. So the volume will be 2000 times pi. So we're going to leave our answer in terms of pi. So we say it's 2000 pi centimeters cubed. And then the volume of the cone here, we're going to multiply 1/3 by pi by the radius squared, so 6 squared. Multiply that by the height, which is 30. Now I know here that 6 squared is 36. So it's going to be 1/3 times pi times 36 times 30. And when I find 1/3, I divide through by 3. So if we have a look at this 1/3 and this 30, then I know that 1/3 of 30 is 10. So it means that I'm only working out 10 times pi times 36. So I managed to break the problem down. And now I can multiply 10 by 36, which gives me 360. So it's 360 times pi. So in this case, we say it's 360 pi centimeters cubed for the volume of the cone. And in this question, we were being asked to find the difference in the volumes. So the difference, we worked out by subtracting the smallest volume by the larger volume. Okay, so 2000 pi minus 360 pi. So if we take 360 from 2000, leaves us with 1640. So that's pi. And our units for volume are centimeters cubed. So that's the difference in volume between the two shapes. And our answer is in terms of pi as well. Okay, I hope this video has helped you with some of these topics, and stay safe.